Hey guys, today we are working on natural logarithms and base E. So whenever we're talking about natural logarithms, we might have seen some examples that we did not review, but that's our LN, that stands for natural logarithm. And our base E is actually a value that's given. It's kind of like pi, it has a value. It's like 2.78, super long number, but your calculator knows that value, and all you have to do is put that value into your calculator. So you don't have to worry about knowing or memorizing that value, but it is a value whenever we're talking about natural logarithms. It's just a number that we know. It's just like pi, except it's called E. Okay, so what is a natural logarithm? It's a logarithm with a base E. It's called the natural logarithm. So we can use log E, but it is also more often denoted by Ln, which stands for natural logarithm. So the way we're going to write our natural logarithm would be just like Ln. Whenever we have x, remember we're knowing that that has a base E, okay? And so here we want to review some of our properties of logarithms. So we know whenever we're dealing with nothing, no base right here, we know it's base 10. So 10 to what power would equal 10? Well, we know that's 1 because of our properties. Our log base 10, 10 to what power equals 1? We know anything to the power of 0 is going to equal 1. And then we know when we're adding, we're multiplying, when we're subtracting, we're dividing. When we have a coefficient, that's an exponent. So we know all of these properties. Now we're going to see how those properties work with natural logarithms. So with natural logarithms, kind of same thing. We know this is a base E, so E to what power equals E? Well, we know it would be 1. And here we have E to what power would equal 1, which would be our 0 property. Here, whenever we're talking about our natural log, we're multiplying. If we wanted to expand it, it'd be our natural log x plus natural log of y. Here, when we're dividing, we have our natural log of x minus our natural log of y. And our fifth property would be our exponent property, which would turn into a coefficient. So I would have n times the natural log of x. So all of these are the same as my logarithms, except now we're dealing with natural logs. So some examples. Let me go ahead and change the color real quick so you guys can see. So some examples, I have a natural log of e to the power of 5. Well, we just said that when we have an exponent, we're going to move it to the front as my coefficient. So I have 5 times the natural log of e. Well, when we look back at my properties, I know the natural log of e equals 1. So I'm going to go ahead and plug that in. So natural log of e is 1. So I'm just going to replace it with 1. 5 times 1 is 5. My answer would be 5. Let's try the next one. We know when I have an exponent, it's going to get moved to the front as a coefficient. So I have the natural log, negative 3 times the natural log of e, plus 12 times the natural log of e. So here, kind of almost just like the same, guys, we know this equals 1, but we also know that this just can be dropped. So it's kind of the same as dropping my exponents as multiplying. So it'd be negative 3 plus 12, which would be positive 9. Here we know we're dividing. When we're dividing, we are going to subtract. So I have 1 minus the natural log of e to the 24th. We're going to keep on the natural log of 1. If you go back to our properties, we know the natural log of 1 is 0. So I'm going to go ahead and go back and replace that with 0. And we know this is going to be brought down as a coefficient, so minus 24 times the natural log of e. We know that equals 1. So I would have 24 times 1. 0 minus negative 24 times 1 is negative 24. 0 minus 24 is negative 24. So my answer is negative 24. So all we're doing is simplifying these expressions and figuring out what my natural log would be equal to. Now, whenever I'm talking about condensing, so we're just going to turn this into a multiplication or division problem. So here I have the natural log of 16 minus the natural log of 4. Well, we know when we're subtracting, we are going to be dividing. So I'm going to divide 16 divided by 4. Well, what's the natural log? 16 divided by 4 is 4. So that would be the simplified version of this. Same for number 8. I have 3 times the natural log of 3 minus the natural log of x plus the natural log of x minus the natural log of 9. So now I'm going to go ahead, let's start with the first parenthesis. So I have subtraction, that means I'm dividing. So I have 3 divided by x. Plus, here I would have my natural log of x, I'm subtracting, I'm going to be dividing over 9. Now here I have this as a coefficient. Remember, that means it gets turned into an exponent. So I'd have the natural log of 3 over x to the power of 3 plus the natural log of x over 9. 3 to the third power, 3 times 3 times 3 is 27. X to the third power is x to the third power. And that's my natural log. Now here I'm adding. So now I know I'm going to be multiplying these numbers. So I have 27 times x over 9 and over x to the third. So now I'm going to multiply these. 27 times x is 27x. X to the third times 9 is 9x to the third. That's going to equal the natural log. We know 27 divided by 9 is 3. And then we know x divided by x to the third. Whenever I'm dividing exponents, I'm going to subtract. So I have 3 minus 1 is 2, and it's going to stay where my exponent is bigger. So x squared. You might need to review your exponent properties to remember how to do that. So that would be my answer for number 8. The last one, I have natural log of 20 plus 2 times the natural log of 1/2 plus the natural log of x. So here, let's start with this first one because I cannot do anything with the 20. It stays like as is so far. This has a coefficient of 2, so I know that's going to be 1/2. Well, the natural log of 1/2 squared plus the natural log of x. So 1 squared is 1. The natural log of 1. 2 squared is 4. And then plus the natural log of x. And then I'm going to add, and when I'm adding, I'm multiplying. So I have the natural log of 20 times 1/4, times x. Let me go ahead and erase this one mark. Okay, so let me change back to my pen. Okay, so now I'm going to multiply. 20 times 1 divided by 4 is 5. 5 times x is 5x. I would have the natural log of 5x. That would be my answer. Okay, now we're going to talk about solving. So whenever I'm solving, we're just going to simplify this into the most simple form. So first I want to get my x by itself. That's my goal, is to get this x by itself. So first I'm going to take away the subtraction. So I'm going to subtract 1 on both sides. -4 minus 1 is going to be -5. Now I'm going to divide everything by -2. I have the natural log of x equals -5 divided by -2, negative, and a negative is going to become positive. Now we know our base here is e. So let's just think of rewriting this in exponential form. So we have some e to the 5/2 power is going to equal x. So if I rewrite that as e to the 5/2 power equals x, then I know e to the 5/2 is my answer. We're going to leave it as e to the 5/2 because otherwise I end up with some ugly decimal. We're just going to always write this using e because it helps us get prettier numbers and prettier expressions than these huge long decimals, okay? Very large numbers. So my answer would be e to the 5/2 equals x. Let's go ahead and try this next one. And we have, first we're going to divide by this 3. To get rid of that so I can start solving. So 24 divided by 3, I have the natural log of x plus 2. 24 divided by 3 is 8. And then I'm going to take the natural, I'm going to rewrite this as in exponential form. Remember, we have base e. e to the 8th power is going to be equal to x plus 2. Now I need to finish solving, so I'm going to subtract by 2 on both sides. So I would have e to the 8th minus 2 equals x. And that's how you would write that answer. Some of these are going to equal nice, pretty numbers, and you're going to be able to drop your bases on both sides because you'll have them on both sides, and I'll show you an example next, okay? But if not, you're going to leave it just like this. So here I have the natural log e to the power of L, or natural log of x, plus the natural log of e to the power of the natural log of x squared equals 2 times the natural log of 8. So I'm going to go ahead and start fixing this. So we know we would bring down my natural log of x. Remember, our natural log of e is the same thing as writing 1. So I'm going to go ahead and just rewrite that. So and then I would have natural log of x squared times 1. So this is the same thing as just having ln x times ln x squared equals 2 times the natural log of 8. So now I'm adding, so I want to multiply. So I would have the natural log of x cubed, because x times x squared would be x cubed, equals, and this coefficient, remember, is an exponent. So I would have 8 squared. I have a natural log on both sides, both with the base e, because we understand that there's an e there. So remember, I can drop my bases from both sides. So I have x cubed equals 8 squared. So x cubed, 8 squared first is 64, and then I have x cubed. Well, the opposite of cubing something is taking the cube root. So I want to take the cube root on both sides. So cube root of 64, if you plug that into your calculator, I get x equals 4. So there I actually get a nice pretty number because I can drop my logs from both sides, my natural logs. Okay, so you're going to see some like that in Schoology, and you're just going to work it just like this example. So make sure you write down this example and you do understand it. Now for Delta Math homework, you're going to have some homework in Delta Math and some in Schoology, a little bit of both. The one for Schoology, here we have 2 times the natural log of 8x plus 1 plus 14 equals 30. So first I want to get rid of everything outside. So I'm going to start with my minus 14 and get a 16, which is 2 times the natural log of 8x plus 1 is what I'm left with. I still have a 2 out here, so I can divide by 2. So I would have the natural log of 8x plus 1 equals 8. 16 divided by 2 is 8. Now I'm going to rewrite this in exponential form. Remember, I have a base e. So we know e to the power of 8 equals 8x plus 1. And I'm going to continue writing this. So now I need to finish solving. So I'm going to subtract 1 on both sides. Remember, you're going to leave it with the e. And then I have equals 8x. And then now we're going to divide by 8. And so I end up with e to the power of 8 minus 1 over 8 equals x. So my answer would be represented just like that. Let me switch the color so I can write it. In Schoology, you're not going to give decimals because we want the exact answer. The exact answer would not be if I rounded a decimal. Our exact answer, oops, let me go back. Would be e to the power of 8 minus 1 over 8. Okay, so that's how you would write your answer. You might need to use this little keypad here, but that's how we want your answer in Schoology, or not in Schoology, in Delta Math. So make sure you do write your answer correctly. If you have questions, please make sure you ask, and I will be available to answer questions. Good luck on the homework, and we'll see y'all on Friday or Monday.